Okay, so let's talk about exponent properties. So the first thing is let's list the properties. So the exponent properties are, if you have two of the same bases, right? So one base multiplied by another base, you just add the powers. Okay, if you have a base raised to a power, so this is a power raised to a power, then you just multiply the powers. A base with a power of 0 will be 1. And this is true for anything but 0 to the 0. I didn't really put that, but that's the thing. Okay. A to the negative power is the same thing as 1 over a to the positive power. And lastly, we have a to a rational power, which is a fraction of a power. The numerator is the actual power, and the denominator is the root. And this can go both ways. Right? I can have the root outside and the power on the inside, or I can do the root and then have the power on the outside. It doesn't make a difference. They're all equal. All right. Okay, so those are our properties. Let's investigate why these are true. All right, let's start with this. So we'll have multiply like bases and raise a power to a power. So if we have something like this, let's say 2 cubed times 2 to the 4th. Well, this is 2 times 2 times 2, which is 2 cubed, times 2 times 2 times 2 times 2, so 2 to the 4th. So this is really just 7 2's multiplied together. So this is 2 to the 7th. Well, it's not a coincidence that there are 7 2's and there's a set of 3 2's and a set of 4 2's, so I can just add the powers. So when you multiply like bases, that's why you add the powers, because in reality, it's just multiplying all the total pieces together, right? Okay, so now what if I add 2 cubed to the 4th? Well, 2 cubed is easy. It's 2 times 2 times 2, and now this is to the 4th power, which means I'm going to have 4 of these multiplied together. So I'll have 2 times 2 times 2, 4 times. Well, add these up now. So 2, there's 3, 6, 9, 12. So I'll have 12 total 2's. Well, how did I get to 12? Well, I can do a simple shortcut, and I have 3 of these 4 times, so 3 times 4 is 12. So that's why we get a power raised to a power is multiplication. Okay? So it's really just a shortcut to this multiple multiplication idea. All right? Okay. Let's try this. Let's figure out how we got a to the 0 equals 1, and how we got a to the negative n equals 1 over a to the n. And in fact, a to the 0 actually equals a divided by a, which is weird. All right, so to do this, the easiest way to do this is just to do a general, quick little simple sequence. So I'm going to take 2, and then to go to the right, I'm just going to keep multiplying by 2. Okay, so 2, the next term is 2 times 2, which is 2 squared. Then the next term is 2 times, or another 2, which is 2 cubed. So notice as I go to the right, I multiply a 2. And when I keep multiplying by 2's, I just raise the power by 1. All right, so if I wanted to keep going, I'd have 2 to the 4th, 2 to the 5th. Also notice that if I want to go in the other direction, so if I want to go left, I divide by 2. So 2 to the 4th divided by 2 is 2 cubed, right? 2 to the cube divided by 2 is 2 squared. 2 squared divided by 2 is 2, right? And so I actually decrease the powers by 1 when I go to the left, all right? So to go to the left, divide by 2 and decrease the powers by 1. Well, that tells us a ton here. So 2 to the first, my next one divided by 2 would be 2, 0, divided by 2, 2 to the negative 1, and all that good stuff. So this actual simple little sequence reveals a ton. All right, so we can understand quite a bit here. So here's our sequence, and now I know, right, 2 squared is, or 2 to the first power is 2. I know 2 squared is 4. I know 2 cubed is 8, so I'll have a 2, 4, 8, 16. So 2, 4, 8, 16. And remember, to go to the left, I divide by 2. So 2 divided by 2 is 1. 1 divided by 2 is 1 half. 1 half divided by 2 is 1 fourth. All right, so that's how I get these terms. So going to the right, I add 1 of the exponent. To the left, I subtract 1 of the exponent. To go to the right, I multiply by 2. To go to the left, I divide by 2. And now both these sequences are equal. So look at this right here. So it says 2 to the 0 equals 1. And really this 1, right, is 2 divided by 2. So remember, when I go to the left, it's 2 divided by 2. So this 1 is really 2 divided by 2. It's very interesting. That's why the a to the 0 power equals 1 is actually a divided by a. Also, look at this. Here it lets me know too, this equating sequences lets me know that 2 to the negative 1 is actually the same thing as 1 half. And 2 to the negative 2 is the same thing as 1 over 4, and 4 is 2 squared. So this lets me know that a negative power is simply just a reciprocal. So a negative power just produces a reciprocal. All right, that's how I get that reciprocal identity. All right, our last identity is this, right? Our rational exponent. So if we have a fraction as an exponent, it could be either, right, the root and then the power on the inside, or the root and the power on the outside. I'm going to show you two ways to do this. So the first one is with this whole sequence idea. So let's actually look between the 2 or the 1 here, right? Because 2 to the 0 power is 1 and the 2. So remember last time I did 1, 2, 4, 8, but I want to look in between these. So I'm just going to pick a random number. So I'm going to put 2 spaces in between. So I'll multiply this by something to get this number, and then this by something to get this number, and then this to get that number. So remember, when I go to the right, I still do my multiplication. Okay? So going to the right, still multiplication. So here's the deal. I need to multiply this number once, twice, 3 times to get this number. So I'm just going to do some number x that I multiply together 3 times. So x times x times x is x cubed. And that has to equal 2, right? Again, because this 2 to the 0 is 1. So 1 times x, and then times x, and then times x has to be 2. Well, cube root both sides, it means that the number that I needed to multiply by had to be cube root of 2. Right? So now I know my multiplier. So in the big one, I just multiplied through by 2. This, when I split it up and look in between, I'll multiply by cube root of 2. Right? So if that's the case, let's do our sequence. So 2 to the 0, multiply by cube root of 2. And then to the next term, multiply by cube root of 2. And then multiply by cube root of 2, and I'll get this. Right? Same thing. So multiply going to the right, and then I can also add to increase the powers. And since I need to add 3 times, and I need to go from a 0 to a 1, I'll add 1/3 each time. All right, so 2 to the 0 will be 2 to the 1/3. Then add another 1/3, which is 2/3. Add another 1/3 is 3/3, which is 1. All right, and so now I'll equate these two sequences. So you'll see here 2 to the 1/3 is the same thing as cube root of 2. And here, 2 to the 2/3 is the same thing as cube root of 2 squared. All right, so this looking in between lets me identify these equivalencies again. All right, so it shows me these rational exponents, these fractions as exponents can be radicals and powers. All right, so we have this. So remember before I said it could be cube root of 2, the whole thing squared, or cube root and then 2 squared on the inside. All right, so let's take this. So you'll see if I have 2 to the 2/3, I could split that up as in 2 to the 1/3 squared, right? And so remember, powers raised to powers, I multiply. So 1/3 raised to the power 2, I'll just multiply, that's 2/3. So then 2 to the 1/3 is the cube root, and then square on the outside is a square. Okay, so I just pretty much broke up what we already had. Right, just showed how I can break up the pieces to get this. Well, I can also write 2 to the 2/3 as 2 to the 2 times 1/3, right? Because 2 times 1/3 is still 2/3. Well, now look, the 2 squared is on the inside, and the 1/3, which is a cube root, is on the outside. All right, so this is how I can show that 2 to the 2/3, so 2 to the rational exponent is, or are both of these. It's equivalent to both of these. Okay. All right, you can also do it. Let's do method 2 here. I'm going to use inverse operations. So I want to figure out what 2 to the 2/3 represents. So I don't know what it represents. I'm going to set it equal to x, and x will be whatever it represents. So let's do the inverse operations. So we know about powers raised to powers. So 2/3 raised to a 3/2. Let's raise both sides to 3/2. So then I'll get 2/3 times 3/2. And 2/3 times 3/2, right? 6 divided by 6 is 1. So this will just be 2 equals 3/2. So I pretty much did inverse operations, right? I did, here's a square, so I square rooted with its half. Here's a cube root, so I cubed with this 3. All right, so now here's what I have. I have 2 equals x to the 3/2. Now let's do the same thing. Let's go inverse operations, but let's go backwards. So now let's do this. I want to get rid of the 2 in the denominator, so let's square both sides. So now I have 2 squared, and then this 3/2 times 2, these 2's will divide out. So I'll be left with a 2 squared equals x cubed. And now how do I get rid of the x cubed? Let's just cube root both sides. And that's how you'll see that x is actually cube root of 2 squared. So I have that x equals 2 to the 2/3, and x also equals cube root of 2 squared. Right? So that shows me that these two are equal. All right. Then I can do the same thing I did before, mix this up, and then to show that it's going to actually also equal cube root of 2, the quantity of the whole thing squared. All right. Okay. So those are our exponent properties.